Hello students and welcome to our today's class. Today's class we are going to focus more on the measures of dispersion, an area that I started or I introduced in our previous session. I did introduce the area by saying that when we are calculating the measures of central tendency, the single value that we get out of that, either in terms of the mean, the mode, or the median, that single term is a representative for the entire data from which it has been calculated from. But that does not say every element or every x value in the data is actually the same as the mean, the mode, or the median. It is actually a representative. So when we have something like the mean class, the mean score for the class is maybe 48%, it does not really mean that everybody in that class scored 48%. We have got those who scored above 48%, and we have got those who scored below 48%. So we want to know how far is the mean from the real data from which it was computed from. And therefore, we normally use the measures of dispersion to measure that. So I want us to go straight to the measures of dispersion, and I'm going to start by revisiting the range, which was one of the methods of measuring the dispersion, as we move ahead to other measures. So allow me to display my working board so that you can be able to understand it better. Therefore, today I'm going to revisit on the range, and then we move to the standard deviation and the variance. So we start with the range. The range, we said, it is a measure of dispersion where we normally get it through the difference of the highest value and the lowest value. And before we lose track, a data is going to be a representative of itself if the dispersion is very small. The lesser the dispersion, the correct is the measure of the central tendency. So if you have data for the ungrouped case, this is for the ungrouped. Remember, ungrouped data is data that resembles the following. So if you have 48, 51, 36, 70, 37, like that, this is ungrouped data because this data has not been organized into classes. If you are told to get the range, it is going to be the highest value minus the lowest value. So it is a matter of looking for the highest value here. You can be able to realize the highest value is 70 minus the lowest value, which is 37. If you get the difference between those two values, you realize that the range is actually 33. The range is 33. That is how simple we normally get the range. And the smaller the range, the more accurate is the mean. The more accurate is the mean for that data. But if you find that the range is so big, then it simply means that that mean that is now used as the representative of the entire data, that mean is not actually accurate. That mean is not actually accurate. Let us see for this. For the case of grouped data is data that is organized like this. If you have the data that is behaving like from 5 to 10, 10 to 15, 15 to 20, 20 to 25, like that. This data is normally said to be grouped data. And then you have got the frequency. Remember, these are the classes, and this is the frequency. Maybe this one is 2, 8, 6, and maybe 9. This is a grouped data. If you are looking for the range for the grouped data, it is actually the lower limit of the smallest class. Remember, the smallest class is this, which has got the score between 5 and 10. This is the smallest class, and this is normally referred as the highest class. But remember, in a question, it can change. You can have this class 20 to 25 being the first one, 15 to 20 the second one, 10 to 15, and then 5 to 10. It does not have any harm. Somebody can organize it like this so that you have this one as that. But you need to note this, the smallest class, it is the class that has got the smallest value. This is from 5 to 10, which is the same as this. So the range for grouped data, it is the lower limit of lowest class. Lower limit of the lowest class is this. Remember, we have got the lower limit, upper limit, lower limit, upper limit, lower limit, upper limit, like that, lower limit, upper limit. So the lower limit of the smallest class, which is actually this, and then you compare with the upper limit of highest class. The highest class is this one, because it has got the highest value, which is 20 to 25, because 25 is the highest. So you take this as the upper limit of the highest class. And therefore, the range is going to be upper limit of highest class minus lower limit of lowest class, minus lower limit of the lowest class. In this case now, the range is going to be the upper limit of the highest class, which is 25, minus the lower limit of the lowest class, which is 5. You find that now the range is actually 20. The range is actually 20, like that. So for grouped data, take the highest class and you take the upper limit of that class, then you subtract the lower limit of the lowest class. The difference between the two values is going to give you the range. Like, for example, if this were the marks, those who scored between 5 marks and 10 marks, they were 2. 10 to 15 marks, they were 8 students. 15 to 20, they were 6 students. And 20 to 25 marks, they were 9. So the lowest mark that was scored is actually 5. And the highest mark that was scored was 25. So the range is now between the 5 and 25, which is the same as the difference between the two. You get the range of the score, like that. Having looked at that, we can look at another measure of dispersion known as the standard deviation. Standard deviation, commonly denoted by a sign like that resembles like that. So the standard deviation, again here, we are going to look at the standard deviation from ungrouped data. Standard deviation from ungrouped data. Ungrouped data, remember, is data that is having or separated, figures separated by commas, like maybe 12, 13, 9, 8, 15. This is ungrouped data. So if the data is ungrouped, the standard deviation or that sign is normally given by the square root of the summation of x minus x bar squared over the summation of n, of f, of n actually. So this is how we normally do it. The first thing that you need to do is to get the x bar. Remember, x bar is the mean. And so far, we looked at how we calculate the mean from ungrouped data. So x bar, in this case, is going to be the sum of x over n. In this case, it will be 12 plus 13 plus 9 plus 8 plus 15. Then we divide by, there are 1, 2, 3, 4, 5. Then we divide by 5. Then we are going to get what? So this is going to give us 12 plus 9 plus 8 plus 15, which gives us 57 over 5, which is 11.4. X bar is 11.4. Now, having obtained the X bar, then it becomes very easy for you to apply this formula. If X bar is 11.4, you can come here and say X bar is equals to 11.4. And we know the standard deviation is given by the square root of summation of X minus X bar over the summation of n, or n for that case. So what we need to come here and do is to get some columns. So we can have our x values, they are what? They are 12, 13, 9, 8, and 15. 12, 13, 9, 8, and 15. You arrange them downwards like that. Those are your x values. Then now you can have x minus x bar. Remember, this is x bar is here. Then we can have x minus x bar into bracket squared. So you need to fill this table, and then you should be able to get the standard deviation from that computation. So x minus x bar, you take each and every x, then you minus the x bar, which is 11.4. So like here, we are going to have 12 minus 11.4 because this is our x bar. So 12 minus 11.4, which is the same as 0.6. Then you square. Remember, this is x minus x bar. So x minus x bar squared, you just square the value for x minus x bar. So you square it so that it can be faster for us, which is the same as 0.36. Then here it is 13, which is x minus x bar, which is 11.4. Which is 1.6. Then you square that value so that you can get x minus x bar squared, 2.56. 9, which is x minus x bar, which is 11.4, which is negative 2.4. Then you square that, you get 5.76. Remember, x minus x bar, all the values are going to be positive. In x minus x bar, it can be negative, but once you square, all of them becomes positive. So in this case here, it is x is 8 minus x bar, which is 11.4, which is negative 3.4. Then you square, you get 11.56. Here it is 15 minus 11.4. You get it is 3.6. Then you square that, you get 12.96, like that. Now, the formula talks about the sum. Remember, this sign simply means the sum. So we need to sum all x minus x bar squared so that we can get this. We sum all x minus x bar squared so that we can get this value that we are going to use here. So I can add it upwards. 12.96 plus 11.56 plus 5.76 plus 2.56 plus 0.36. You get it is 33. The summation of x minus x bar squared is actually 33.2. So our standard deviation will be equal to the square root of the sum of x minus x bar is 33.2 over n, which is actually 5, which is going to be what? Divided by 5. You get it is actually the square root of 6.64. So the root of the answer which is actually, this is standard deviation. The standard deviation here will be positive or negative. The answer will be positive or negative 2.58, and that is the answer. So it is just a matter of having the x bar first, and then each and every x value that you have, you minus the x bar that you have calculated so that you can have this value. Then this value, square it so that you can have the x minus x bar squared. You do the same to all the values of x down the table as you fill these two columns. And then of interest will be the sum of this column. You sum all the values that you have in that column so that you can have the figure that you are going to put here on the numerator, and then you divide by n and you get that. That is how we get it from ungrouped data. Let us look for a case of the grouped data. For grouped data, or before that, you can have another scenario like this. Maybe you are told that the shoe size of children is given as follows. You are given the shoe size, and here you are given the number of children. You are given like maybe shoe size 3, 4, 5, 6, like that. And then the number of children who wear shoe size 3, there may be 4. This one, there may be 2. Number 5, there may be 1. And this one, there may be 3. So I think you can be able to interpret those who are wearing shoe number 3, there are 4 children. Those who are wearing shoe number 4, there are 2 children. Number 5, there are 1, 6, there are 3. Now you are told, can you compute the standard deviation? Can you compute the standard deviation? What you need to do here, first of all, you get the mean, you get the x bar, you get the x bar. But the formula is going to change slightly here. The formula is going to change slightly here. Remember, the number of children is the same as our f, the frequency. So the standard deviation will be equal to the square root of summation over f into x minus x bar squared over the summation of f, over the summation of f, like that. So we need to get the x bar first. We need to get the x bar first. How are we going to get the x bar? The x bar, we get it like this. The x bar, we shall get it like this. Here is our x values, and here is our f. So we need to know that x bar in this case will be the summation of fx over the summation of f. So we need to get fx here, which is going to be f times x, f times x, f times x. This one is going to be 4 times 3, which is 12, 2 times 4, which is 8, 1 times 5, which is 5, 3 times 6, which is 18. So if we add this, what are we going to get as the sum of fx? So we have 18 plus you get it is 43. What about the sum of f? The summation of f, this is 6 plus 4, which is 10. So the mean here, x bar is going to be 43 over 10, which is the same as 4.3. That is the mean. So once you get that, you come here. Let me create more space here. You will come here and do this. You will have x minus x bar. Then you will have x minus x bar squared. Then you will have f into x minus x bar squared. And that one will sort our question. So x, remember, is what we have here. X bar is what we have here. So we are going to have each and every x, we subtract the x bar. which is 4.3. So we are going to have 3 minus 4.3, which is actually negative 0.7. Just a minute. Sorry, it is negative 1.3. Negative 1.3. So let me have it like this. So we have 4 minus 4.3 is going to be negative 0.3. But I think we can square it just direct so that we can fill each and every row. So 3 minus 4.3 is negative 1.3. If we square that, you get it is 1.69, because this is x minus x bar squared. So you square the value you have for x minus x bar here. Then the value that we have here now, which is x minus x bar squared, we multiply by f, which is 4. So 1.69 we multiply by 4, you get is going to be 6.76, like that. You come here, you find 4 minus 4.3 is negative 0.3 squared. You get it is 0.09 times f, which is 2, which is the same as 0.18. You come here, which is now x is 5 minus 4.3, which will give you 0.7 squared, which is the same as 0.49 times f, which is 1, which is the same as 0.49. You come here, our x is 6 minus x bar. You get it is 1.7. You write here 1.7. You square that. You get it is 2.89. Then you multiply by f, which is 3. You get it is 8.69. So it's a matter of working with the formula that we have here. You have x minus x bar. So you just take x, you minus the x bar which you calculated. Then it is x minus x bar squared. You just square the value that you had there, you fill here. It is x minus x bar squared times f. So whatever you have here, which is x minus x bar squared, you multiply by f so that you can get this. You do the same to this. Now, because the formula says that the standard deviation is going to be the square root of the summation of f into x minus x bar squared over the summation of f, it is going to be the sum of this f into x minus x bar squared, which is what we have here. We just sum all of them, which will be equal to what? 8.69 plus 0.49 plus 0.18 plus 6.76. You get it's giving you 16.1. So it is going to be the square root of 16.1 over the summation of f, which was 10. So divide by 10, you get it is 1.16. The square root of 1.16, the root of that answer, which is the same as plus or minus. This is the standard deviation, plus or minus 1.27. That is the answer to that question. I hope you are able to understand that. Lastly, I want us to do the standard deviation from the grouped data, so that now you can be able to tackle any question that comes along your way with regard to standard deviation. And you can have a very simple exercise like this. Maybe you are told the profit that was realized by companies was given as follows. So you have the profits, but remember, grouped data, the data must be in classes. So maybe you are given 10 to 20. This profit is maybe in thousands. 10 to 20,000, 20 to 30,000, 30 to 40,000. Just a minute. $30,000 to 40,000, and maybe 40 to 50,000. So the number of companies that realize that there may be, these are number of companies. So we have got, actually they are our F. So we have there maybe 3, 4, 2, and maybe 4. Now you are told, can you calculate the standard deviation? The formula remains the same as the one that we have just tackled. The standard deviation is the same as the square root of f into summation of f into x minus x bar squared over the summation of f. So what you need to do is to get the x bar first. Remember, x bar, which is the mean, is the same as the summation of fx over the summation of f. But for us to be able to get x when we have classes, our x will be the midpoint. The midpoint of these classes from 10 to 20. What is the midpoint? You just add the lower limit plus the upper limit, then you divide by 2. 10 plus 20 is 30. 30 divided by 2 is 15. 20 plus that is 50. 50 divided by 2 is 25. 30 plus 40 is 70. 70 divided by 2 is 35. 40 plus 50 is 90 divided by 2 is 45. So x is the midpoint of the classes that you have here. Now you can have your fx, so that you can have here. So fx is simply the x, the f value times the x. So here it's going to be 3 times 15, which is 45 for the first class. F times x, 4 times 25, which is 100. 2 times 35, which is 70. This is going to be 180, which is 4 times 45, 180. So you get the sum here, the sum of fx, which is going to be what? You get it is going to be 395 over the summation of f is what? This is 7 plus 6 is 13. So you can get now your x bar is going to be 395, which is the summation of fx over the sum of f, which is 13, giving us what? 30.4. So having done that, now we can be able to get this. So you can get x minus x bar squared f into x minus x bar squared, and then you will be sorted. So the x minus x bar, remember x is here, our x bar is this one. So we just minus each and every x, we minus the x bar. So we are going to have 15 minus 30.4, which is the same as negative 15. Then you square that. You have 237.16. Then you multiply by f, which is 3. You get it is 711.48. You come here, x is 25 minus x bar minus 30.4. Which you get it is negative 5.4. You square that, you get it is 29.16 times f, which is 4 for this class. You get it is 116.64. You come here, our x is 35 minus 30.4. You get it is 4.6 squared 21.16 times 2, which is F 42. You come here, it's 45. 14.6 squared to 13 times 4, 852.64. Now you add the F into x minus x bar squared, which is going to be what? Plus 42.32 plus 116.64 plus 711.48. You get here, the answer is 1,723.08, like that. Now you can be able to get your standard deviation is going to be the square root of F into x minus x bar squared, the sum here, it is this value that we have here. So it's going to be 1723.08 over the sum of F, which is 13. So we divide by 13, which comes to the square root of 132.54 root answer. The square root of that comes to 11 plus or minus 11.51. And that is how we get the standard. So in all cases, the starting point is first of all to get the x bar. You must start by x bar, and then now you apply the formula for you to get the value that you are looking for. If you do so, your work is going to be very simple. And actually, the good thing about this is that it has a formula. And once you have got this these columns, which are going to assist you in getting the right summation that you require here, then you are home and dry. Thank you very much.